Pacific Ocean over here. And basically, the way the plates work is that whenever you have one of these plates coming together and one of them, the Pacific plate, diving under this continental plate, you always rumple up the surface of the plate that's being underridden, and you get basically a coastal range. And so pretty much all the way through the length of the North Pacific coastal region, you'll see these coastal mountains, which are largely associated with tectonics associated with that plate. Then you get further back away from where the ocean currently is, and you get into the volcanic material, which is where the hot stuff's coming up through the surface, through the crust, and you're getting volcanoes. So, for the most part, these coastal ranges are sedimentary and metasedimentary materials that have been morphosed by the tectonic activity. So, basically, this is just a mountain range that, for the most part, has been pushed up through tectonic activity associated with the plates coming together. But there is a considerable amount of volcanism around, kind of a U shape around the Olympic core, and then this material, including Mount Olympus, which is the highest peak here, is basically sedimentary and metamorphosed sedimentary material. So there is some volcanic material around the eastern rim. Obviously, in terms of weather, the influence here is predominantly the marine system. We get predominantly marine airflows. This is where our moisture comes from. Come in off the ocean on westerlies, headed into the continent, and they carry a lot of moisture with them. And if, in fact, this was just flat, you'd get some moisture out of it, but it wouldn't be humongous in terms of amount. But because you have all of this topography, basically these saturated air masses that are coming in are forced up in elevation to go over the range, and in that process they cool, and they can't hold as much moisture when they cool, so as they're forced up, you get really heavy precipitation coming out of it. That's called orographic precipitation, orographic precipitation, and it's associated with the consequences of these air masses being forced up. Actually, the heaviest rainfall is not primarily right along the coast, as the air masses haven't been forced up very much at that point. The real heavy precipitation is basically here, after basically the masses have been forced up to their highest elevations. But there's several valleys here that are glacially carved valleys that, even though they're low elevation, they're getting the effect of those air masses being pushed up, because even though they're at low elevation, the air masses that are carrying the precipitation are being forced up under them. And this is the Quinault. We'll visit that on Sunday. This is the Queets, and this is the whole river drainage. And those are the three great river valleys of the Olympic Peninsula. They're the rainforest valleys, as they're known. And because they're glaciated, they're very broad valley bottoms. But as I said, they're very, very wet. And so you might have, precipitation of 40 or 50 inches along the coast, but as you get into the front of the range, and as you get up these valleys, the precipitation is up in the range of 100, 120 inches, 140 inches. They're wet. Now, they do dry out some during the summer because we have a very seasonal distribution of precipitation. It's not equitable at all. But even during the summer months, particularly these valley forests and the coastal plain itself, gets a lot of influence of marine air masses. And so you often have low clouds in the summer, particularly early in the day, going up the valleys. And so you actually, as I'll talk about, you get a lot of Sitka spruce, for example, which is a rather drought-sensitive species, extending all the way up these valleys because they're never really subjected to much in the way of drought stress. So marine air masses come along, forced up, obviously a lot of snowfall once you get to 5,000, 6,000 feet elevation. So a lot of glaciers, for example, on Mount Olympus. But then, as the air masses get over to the east side of the peninsula, the elevation's going down, particularly as they get right over to the east end. And so these air masses are drying as they go down slope because they're warming. They can hold more moisture. They aren't giving up a lot of moisture, so you get a very, very strong rain shadow around the east side here, where the precipitation goes down. We went through Sequim. Sequim is famous because it's one of the drier places in the state of Washington, at least in western Washington. Precipitation here at Sequim is less than 20 inches a year, so really quite dry. Now, don't think it's a banana belt just because of that. It is, very mild, but there's an awful lot of clouds there, so you don't get a humongous amount of sun because you get a lot of clouds, both high clouds persisting as they move over, and then marine air moving in. And of course, this is Whidbey Island, part of the San Juans, and the San Juans are famous for being, quite dry. And again, it's because they're really in the lee here of the peninsula. So that tells you a little bit about geology, tells you a little bit about climatic conditions, okay? And you do have a very strong temperature gradient as you go up. And by the time you get to 2,500, 3,000 feet here, you're going to have a persistent snowpack for much or most of the winter. And of course, by the time you get to about 4,000 feet, you're into mountain hemlock. Anytime you're into mountain hemlock and Alaska cedar, you know you're in a snowy environment, extended snow accumulation during the winter, very late departure in the spring, often snow remaining well into July, just depending on the situation. So you do have a strong temperature gradient. So that's kind of the climatic setting. Very wet on that side, quite dry on that side, strong marine influence. The biota here, I'll characterize it primarily by the major forest types. And the predominant type at low to mid elevations here, once you get away from the ocean influence, is really a Douglas fir, western hemlock, western red cedar forest, very characteristic forest of the Pacific Northwest, of the west side. Those three species really dominate in the mountainous portions of the peninsula up to 3,000 feet, for example, 2,500, 3,000 feet. And also, which indicates kind of how cool and damp it is, Pacific silver fir is pretty common, actually at almost all elevations here as well. But basically what we would call a western